and thank you for joining me today. My name is Jeetu Krishnamurthy, and I'm the VP for AWS Analytics. I've always been a data geek. As a technology, I find that databases, analytics, and machine learning offers a compelling combination of hard technical challenges and ability to impact people and businesses. There has never been a better time to be a data geek because as organizations are actually embarking on their digital transformations, we are seeing an explosive growth of data. And this creates a tremendous opportunity for this technology. However, 2 out of 3 organizations are still struggling to gain value from all of this data. So how do you become data-driven and seize this opportunity? You need a trusted partner. AWS has 15 years of experience enabling customers to unlock value from all of this data, including third-party data, at scale. We delivered the first scalable object storage with S3, the first big data processing in the cloud with EMR, and the first cloud data warehouse with Redshift. We offer the most scalable and highest performing data services to keep up with the explosive growth of data and help organizations to be data-driven in real time. We are helping our customers unify diverse data sources by investing in a zero ETL future so that you can quickly and easily act on all your data, no matter where it lives. We provide the industry's most comprehensive set of capabilities for an end-to-end data strategy for all your workloads. And our services help you enable an end-to-end data governance so that your teams are free to move faster. Data fuels the innovation in digital age. And to fully seize this opportunity, everyone in your organization needs to be empowered to use data to make decisions. To be truly data-driven, you need to break down silos. And today, I want to show you how AWS Analytics can help you break down silos in your organization. We break down your data silos by connecting your data lakes and your data warehouses. We break down your system silos by connecting machine learning with analytics. And we break down your people silos by connecting all your data with everyone in your organization with end-to-end governance. So what would that look like? In a data-driven organization, data becomes an organizational asset. Teams and applications have governed access to all the data they need and from the tools of their choice. And data is put to work every day. And this is not easy because there is no one-size-fits-all formula. Let's look at an example. Let's meet Kate. Kate is CEO of Octank, a company that manufactures and sells toys for learning, both online and in stores. And Kate and her team wants to decide what product category should Octank invest in. To make this best decision, you need information from different teams across the whole company. And every team is collecting data, but they store it in a way that is optimized for their own needs. So this leads to data being siloed across purpose-built databases, APIs, best-of-breed SaaS applications, and end-user tools, data lakes, data warehouses, and more. For this project, you need to find the relevant information from all these systems, unify them, set up the right governance policies before you can even start your analysis. Most importantly, you need to enable people from every team with the right expertise and the right business understanding to collaborate. All of this could take weeks, maybe even months. So why is that? Let's understand Octank's challenges. Like most organizations, Octank has technology challenges like where to unify the data and how to do it. Process challenges like how to secure the right approvals to use customer data. And business challenges like budgets and cost. Octank needs a partner who understands these challenges. And AWS Analytics Services are built to give you the fastest way to get answers from all your data to all your users. We enable our customers to catalog, connect, query, and govern all their data, wherever it lives, using the right tool for the right job. So what would it take to put your data to work? You need to build a modern data architecture, one that puts the data in the hands of everyone in the organization with end-to-end governance, one that breaks down your data silos for analytics on all your data, including third-party data, one that connects your analytics and machine learning systems, one that offers a comprehensive governance strategy to comply with industry and geographic regulations, and one that offers the best price performance. I want to share a couple of examples from customers who built their modern data strategies on AWS. JPMorgan Chase is one of the largest financial institutions, and they manage trillions of dollars in assets and daily payments. They serve every other household in the US and many more around the world. As a 200-year-old institution, JPMorgan Chase has successfully reinvented themselves over and over to deliver new experiences for their customers and optimize their business. JPMorgan Chase partnered with AWS Analytics to build their AI and analytics platforms using services like EMR and Redshift to enable their over 35,000 developers to continue to innovate at scale. JPMorgan Chase is a great example of a storied organization that has been able to adapt and serve their customers in new ways. But they're not alone. We saw Engie, one of the largest utility companies in France, with a global presence in 70 countries at Adam's keynote. They are leading the way to a carbon-neutral future. To accelerate this transition, they partnered with AWS to build out the Common Data Hub, to unify all their data across their 40 business units and make it available to all their people to innovate on. Leveraging AWS Analytics governance capabilities, they were able to meet the complex compliance requirements required by the different countries they operate in. The Common Data Hub has enabled over 1,000 projects since its launch. As you've seen in these examples, the first step to a modern data strategy is unifying their data. Thinking back to Octane, the critical customer and business data is siloed across multiple systems, purpose-built databases, best-of-breed SaaS applications, third-party data ecosystems, and more. To solve business problems like what product to invest in, or how to optimize your distribution channels, you need to unify your data so that your teams can access all the data they need. You need ETL, but ETL is hard. You need to connect to all your data sources. You need to be able to handle system failures and data changes. You need to be able to combine, clean, and normalize your data and make it ready for analysis and machine learning. To do this right, you need experts. That's why we built AWS Glue to make ETL easy. Glue is serverless, and it provides all of the capabilities needed for reliable data integration to build your data warehouses, data lakes, and other data sources. With Glue, you can put your data to work in minutes, and we have built Glue for everyone. ETL developers can process petabytes of data using Glue's Spark-based ETL engine without writing any code from Glue Studio. Business analysts can visually prepare data up to 80% faster by using the over 250 built-in transformations in Glue Data Brew. And data engineers can leverage the full power of Spark and Python using the code-first experience in Glue Notebooks. Tens of thousands of customers are creating reliable data integration jobs in AWS Glue for analytics and machine learning. Our customers love Python for the richness of its library ecosystem, but they struggle to scale it for big data processing. That's why I'm excited to announce AWS Glue for Ray, a new engine option in AWS Glue for data integration at any scale with Python. Ray is a popular open source project that makes it easy to use Python for analytics at scale. AWS Glue for Ray is the first serverless option for Ray framework in the cloud. It starts up in seconds, auto-scales with your data, and you only pay for the resources you use. Glue makes ETL easy, but in many cases, all you want to do is to just ingest your data into your data lake or data warehouses. That's why we are investing in Zero ETL for making ingestion easy. Let's look at Zero ETL, starting with streaming data. Applications use Kinesis data streams, or MSK, for storing and processing streaming data like click logs. Kinesis Firehose gives you a Zero ETL way to load these data directly into your S3 data lakes, Redshift, or OpenSearch service. In just a few clicks, you can enable your dashboard to see data in near real time. And we are making this even easier for Redshift. With Redshift streaming ingestion now generally available, you can configure to directly ingest streaming data into your data warehouse in real time, right from the Redshift console. Now, what if we can also do Zero ETL from relational databases? Yesterday, we announced a preview of Zero ETL integration between Amazon Aurora to Amazon Redshift. Within seconds after your transaction is committed in Aurora, it is made available for analysis in Redshift. With the Zero ETL integration with Amazon Aurora and the Redshift streaming ingestion, performing near real-time operational analytics has never been easier. Now, as we saw in the case of Octank, some of the most critical data about your business and your customers is in SaaS applications. That's why we built Amazon AppFlow. Amazon AppFlow securely transfers data between the SaaS applications like Salesforce, SAP, and ServiceNow to your S3 data lakes and Redshift in just a few clicks. AppFlow also keeps this data updated at a frequency you choose automatically. By using enterprise-ready AppFlow connectors, you can focus on generating insights. With the 22 new connectors, it's now easier to get started with use cases such as optimizing your marketing campaigns, understanding your customer experience, and improving your operations. Now, if you're in an industry like financial services or life sciences, industry data is very important to you. And that's why we have AWS Data Exchange. ADX makes it really easy for you to find and subscribe to data that is relevant for your industry or your business. You have access to over 3,500 public data products from more than 300 providers, or you can subscribe to data products shared privately with you by your business partners. ADX also provides an easy way for you to manage all your subscription in one place. With ADX integration directly into Redshift, you can start using ADX data with Zero ETL. For example, Moderna used Redshift and ADX integration to subscribe to real-world evidence data in real time to create the new generation of transformative medicine using their mRNA technologies. And we have made it easy for you to share your data in Redshift securely as data products through ADX. Now, Zero ETL makes moving data to your data lake and data warehouses easy. But can you get started with your analysis with zero data movement? Yes, you can, with federated queries in Athena and Redshift. In Athena, you can use the familiar SQL construct to join data across Amazon DynamoDB and Google BigQuery for a quick analysis. Athena natively supports querying over 26 different data sources. And using the Athena's Query Federation SDK, you can build connectors to other data sources. Similarly, in Redshift, you can join live data in one or more of the Amazon relational databases and get instant visibility to your end-to-end business operations with no data movement and with high performance. With Glue and Zero ETL services, we have made it easy to unify your data in S3 data lakes or Redshift data warehouses. But your data might still be across data warehouses and data lakes. So why do customers build two systems? Let's think back to Octank. Their finance BI team unified their data into a data warehouse for fast interactive reporting. Their marketing data science brought the social media feeds to analyze product and customer sentiment into a data lake to optimize their marketing campaign. Now, thinking back to Kate's question, the teams need to have access to data from both the data lake and data warehouse to find the right insight. In a modern data architecture, you need the best data warehouse and the best data lake solutions that will work seamlessly together to provide the analysts and data scientists a complete picture of their business. And Redshift is the best data warehouse foundation for your modern data architecture. As a pioneer in cloud data warehousing, Redshift is built to store all your structured and semi-structured data in high-performance formats at exabyte scale. In Redshift, storage is decoupled from compute, enabling Redshift to support virtually unlimited concurrent users and queries at consistently fast performance. And you can also share the live data across your organization. With ACID transactions, Redshift makes it really easy to stay compliant with data retention policies. And I'm happy to share that we have added native integration to data in Redshift from Apache Spark. With this integration, data engineers and data scientists using EMR or SageMaker can instantly access data in Redshift with high performance and transactional consistency. And we are seeing queries running up to 10 times faster in industry standard TPC-DS benchmark. And I'm excited to bring this capability to the tens of thousands of customers who are using Redshift as their data warehouse foundation. It's customers like Pfizer, Moderna, and Johnson & Johnson who are leveraging Redshift to support their drug research and accelerate the fight against COVID. Now, if you're a healthcare or life science customer, like GE Healthcare, you need to analyze not just structured and semi-structured data, but also unstructured data, like medical images or genomic sequencing. And for this, you need a data lake. Data lake lets you store and analyze cost-effectively your unstructured data with all your other data at exabyte scale. By storing your data in open formats, you can choose from the broadest set of analytics and ML services for all your use cases. And data lakes are a critical part of a modern data architecture. And S3 is the best storage foundation to build your data lakes because of its unmatched scalability, reliability, security, and governance capability. It's built from the ground up for 11 nines of durability and to give you the fastest performance at the lowest cost. As customers are actually adopting data lakes for broader use cases in analytics, they need transactions to support deleting data for compliance regulation or for near real-time ingestion. That's why AWS supports open source transactional data lake formats like Iceberg on S3 data lakes. AWS Analytics and ML services now support all three popular open source transactional data lake formats right out of the box. In fact, there are hundreds of thousands of S3 data lakes built on AWS. It's companies like Vanguard, BMW, GE Healthcare, Zillow, Slack, and many more. Now, our most advanced customers have multiple data lakes and multiple data warehouses. They understand that their modern data architecture has to reflect the decentralized reality of how data gets generated and managed in their organizations. and in some cases, even across organizations. These customers build a data mesh. Okay. A data mesh empowers teams to be autonomous and agile. These teams create and share data products to give their organization a full view of their business. For example, the sales team at Octank is responsible for creating and sharing curated data sets about their sales pipelines and customer opportunities. Marketing uses these data products to optimize their campaigns, and finance builds their sales forecast using these data. And this is happening in a collaborative and self-service manner. Now, all of this sharing has to comply with the applicable regulations. You need the ability to govern all your data to meet the regulations specific to your industry and geography. So what would this unified governance look like? You need a central place to set all your governance policies for your data lakes and your data warehouses. And these policies are enforced by all your analytics and ML services that access this data. And you have an audit trail that gives you full visibility on who is accessing your data and for what purpose. And that's why we built AWS Lake Formation. With Lake Formation, you can define access control and audit policies in one place for your S3 data lakes and Redshift data shares. And you can set these policies at various levels. You can grant access to users from across different accounts to access the whole table, only some of the columns, or a subset of rows and columns based on who they are and what their use case is. And you can do all of this without making copies of the data. Let's look at how Octank can simplify their governance with Lake Formation. The sales team at Octank built their data products and stored them into a data warehouse to share it with finance, marketing, and the whole company. They use Lake Formation fine-grained access control to grant access to all the data to the finance team, but restricted marketing access to only data related to specific products to the individuals who are doing the marketing. With Lake Formation, data producers can easily enable governed sharing of data products across the organization. Now, how can we make it just as easy for data consumers to find and get access to this data? And that's why we built Amazon Data Zone. With Data Zone, you have easy discovery and governed sharing of data across the organization. Data producers can easily add their data products to the Data Zone catalog with business context. They can enrich the business metadata for even easier discovery using machine learning. Users can search the Data Zone catalog using business terms like Pacific Northwest sales opportunity, review the results, and request access to the right data. Users can also create projects to collaborate seamlessly across organization to solve business problems. All these capabilities can be accessed through an out-of-console data portal that does not require users to have access to the AWS console. Let's see how Amazon Data Zone enables a data mesh architecture at Octank. Each team would publish their data products organized as a domain in the Data Zone. To make product investment decision, the team would create a project in Amazon Data Zone and add the right people and the necessary data to the project to enable easy collaboration. Now the team is ready to put the data to work using the broadest selection of purpose-built analytics services in the cloud from AWS Analytics. Before I go into more details on the analytics services, I would like to invite one of our customers who has seen tremendous success using AWS Analytics. Please welcome Scott Donaldson, CTO of FINRA CAT.
Thank you. Hi there. I'm Scott Donaldson, CTO of FINRA CAT, and I thank G2 for inviting me to share our story here with you all today. At FINRA, we are a private nonprofit regulator of the US equities and options market and broker-dealer industry. Our mission is investor protection and market integrity. We began our journey onto the cloud back in 2014 and completed our move out of the data center by 2017. But what I'm here to talk about today, that I'd like to talk some more about, is a project called the Consolidated Audit Trail. Now, the Consolidated Audit Trail, or CAT for short, brings together all the information from all the exchanges and industry firms in one single place. Prior to the building of the CAT, the information was segmented and siloed across all of the different regulatory agencies and exchanges, the SEC, NASDAQ, NYSE, CBOE. The CAT solves this problem by bringing together all of the information in a single place across over 1,300 industry firms and 25 exchanges and platforms. The CAT ingests a very complex data set that encompasses technical specifications and reporting scenarios in excess of 1,600 pages. The CAT also provides a rich set of analytics to the reporters themselves and to the regulators in such things as what we call a linkage, which basically is the chain of events, everything from the original order that you may do when you're sitting on a E-Trade in your screen until the execution. We provide rich set of user analytics in terms of audit trails that allow a user to slice and dice the information in any way across date times, issue symbols, and the like. We provide rich sets of what we call depth of market, which allows the regulators to see at any point in time all of the various different price levels across all of the venues at any point in time. And we do this all in a highly secure and regulated environment up on the cloud. With the CAT, the regulators now have unprecedented access to the information that allows them to look at both cross-product and cross-market regulation and things for regulatory interest. These things can involve things such as insider trading, fraud, and market manipulation. But building the CAT was not without its challenges. First and foremost was performance. The CAT has to process wildly fluctuating data volumes on a daily basis, as well as be able to meet fluctuating user needs. It has very strong regulatory requirements and timeframes in terms of SLAs that it must deliver on. From a scalability perspective, we needed to dynamically scale and shrink the environment based on the demand, both from the data submission and processing, as well as the regulatory usage of this. We needed to provide simple, straightforward, ubiquitous access to all of the regulators and all of the information across this, and be able to do this in a very cost-efficient manner. Now, when we look at the CAT, it is really nothing more than a giant analytics processing engine. On the one side, we ingest and cleanse and validate and normalize information from all of these industry members and exchanges. We use things such as EMR, Scala, and Hive to be able to do our data processing and our data pipelines. We then make that information available and searchable across our data catalog, and then provide end-user analytics that range both from query tools to programmatic interfaces that allow data scientists to be able to come and access the information, as well as machine access across the different regulators that come in and query the CAT as a data service and query this in place. All of this is done on top of an S3 data lake. Now, one of the interesting things about the CAT is that we have been, since 2019 when we started building the CAT, that we've been faced with an unprecedented surge in data volumes across the markets. When you look at the 10-year historical trend in terms of trading activity, the volumes have shifted by greater than 2 standard deviation units. That's resulted in US equities markets growing at a rate of over 66% a year, and the options exchange is growing at a rate of over 100% per year. Now, when we look at the CAT, it is a very massive data processing engine. We process, on average, over 500 billion events per day. Our data repository, since we've been in operation in over 3 years, we now have over 250 trillion events that are in our data repository. This data processing that we're doing is 10 times greater than was originally projected when we started on this project back in 2018. To process this information, we use on average over 120,000 compute nodes every day, of which 99.5% of that is completely transient. We spin up EMR clusters, do our data processing and pipeline, write the results out to the data lake, move on to the next step in the workload. That data lake now is in excess of 450 petabytes. But also one of the challenges that we have of the CAT is doing this in a cost-effective manner. This is data processing at massive scale that requires the largest compute instances that we have within the environment that AWS offers. So we partnered with AWS earlier this year on an architecture upgrade to one of the key components, the linker. Now the linker is the process that is a series of over 40 jobs. It brings in the data, it validates it, it finds all of the missing pieces. So imagine every day what we hit as 500 billion jigsaw puzzles that are dumped onto our door every day. Every day we then sort that information, find all the pieces that attach, find all the missing pieces, inform the exchanges in the industry that have all the pieces that are missing. They then submit in all of their corrections, and then we collapse all of that information down into a final linkage processing at the end of the day. To do this, we endeavored on a major upgrade. We moved from EMR 5 and Spark 2 up to EMR 6 and Spark 3, as well as took advantage of the latest Graviton 2 instance classes. The result of this was not necessarily, we exceeded our expectations of 25 to 30% performance increase. We actually reduced our overall productivity and performance by over 50% in terms of that. That has allowed us to shrink the number of clusters and the compute instances in our clusters by over 66%. Some of our largest individual clusters that did individual pieces of work, we have over 1,200 nodes. We are now able to process the exact same amount of data with a third of the amount, with 400 compute nodes in the same or better runtimes. What has this meant is that while the data volumes have continued to grow at unprecedented scale by over 2x, our throughput and performance grew by over 3x, which has resulted in one of the KPIs that we track very closely, what is our cost to process a billion events. We were able to decrease our costs by over 33%. And overall, while the data volumes have grown, have more than doubled, our AWS fees have only grown by less than 25%. But we're not done yet, as we have built the initial part of the CAT. We're looking to leverage additional AWS analytics services, including EMR and EKS as we continue to grow and scale and plan for a trillion event day. We're looking to be able to move to Graviton 3, as well as latest versions of Spark with a push shovel to improve the I/O. And then lastly, we're looking at migrating our data lake onto the transactional data lake with Iceberg. I thank you for letting me share our story here with you today. And with that, I'll turn it back over to G2.
Thank you, Scott. That's such a great story, and Scott and team has been great partners and inspires us to keep innovating. AWS provides the broadest set of purpose-built analytics services. So let's go through them. For SQL Analytics, we have Redshift. For analytics using open source framework, we have Athena and EMR. For log and search analytics, we have the Open Search Service. For real-time analytics, we have Kinesis and MSK. And for business intelligence, we have QuickSight. Let's take a closer look at SQL Analytics and Redshift. The beauty of Redshift is that it is built to break down data silos. You can query your data in data warehouses, in data lakes, and through federated query, your operational databases. Data warehouses are actually becoming mission critical. So Redshift multi-AZ comes in built in with high availability and disaster recovery, with automatic recovery from failures with no data loss. We have automated performance optimizations by leveraging our fleet performance telemetry and machine learning. We can optimize your schemas, rewrite your queries to use materialized views, automate workload management, and more. With all these investments, Redshift offers the best performance at scale, out of the box, at no additional cost. Redshift offers up to five times better price performance on industry standard benchmarks when compared to other cloud data warehouses. Now, benchmarks are great, but what does it mean for real-life workloads? Redshift does even better. For example, we learned that among the billions of queries we execute each day, 90% execute in less than 1 second. These are typically for BI dashboards. Redshift performs up to 7 times better in real-life BI scenarios. Redshift offers the best SQL Analytics experience on AWS. Now, many of our customers also use open source frameworks in their analytics use cases. For them, we built Athena and EMR. Athena makes it really easy to do interactive analytics and is built on open source frameworks. It's serverless, supports a broad set of file formats and transactional data lake formats, and other data sources through federated query. With Athena, you can simply point it to data in Amazon Aurora and join it data in SAP HANA. We have made Athena even better using Athena Engine v3 built on Trino. This new engine comes with over 90 enhancements to make Athena even more powerful. v3 is 20% faster than v2 on TPC-DS benchmark, with some queries running up to 7 times faster. v3 is also up to 10 times faster in query planning, which speeds up short queries common in BI scenarios. v3 is compatible with v2, so it is very easy for you to upgrade your engine. Now, our customers love the simplicity of Athena and have asked us to bring this experience to more open source frameworks like Spark. That's why we announced Amazon Athena for Apache Spark earlier today. Now you can do complex Spark analytics using PySpark with the same instant-on experience and the simple experience you love in Athena. And it is up to 75 times faster to get started compared to other serverless Spark offerings. It's built on the same optimized Spark runtime that powers EMR and Glue, so you have the best performance for interactive analytics using Spark. For big data processing using open source frameworks, we offer Amazon EMR. EMR is the industry-leading cloud big data solution for petabyte scale data processing. EMR supports the broadest set of big data frameworks including Apache Spark, Hive, or Trino. With EMR, you have access to the latest version of the framework within 60 days. You can deploy EMR to your EC2 clusters, EKS containers, Outposts, or you can go fully serverless. You can build your big data processing applications on data in S3 data lakes or Redshift with integrated governance using LakeFormation or the open source Apache Ranger. And you can do all of this with the best performance. The optimized Spark runtime in EMR is 3.9 times faster than the open source version in TPC-DS benchmarks, while remaining 100% open source API compliant. With exploding data volumes and shrinking budgets, our customers are looking for ways to reduce the total cost of ownership for big data processing workloads. And EMR and S3 on AWS is the easiest path to modernize your big data infrastructure. You get the lowest infrastructure costs from AWS, the usage-based pricing, and EMR's high-performance runtimes. With EMR's managed scaling, you no longer have to provision your clusters for peak and pay for the idle instances. Our customers are actually creating over 6 million clusters every month, as you heard from Finra. You can further optimize your costs using EC2 Spot instances, which can be up to 90% cheaper. And EMR on Graviton offers up to 30% better price performance. And finally, with EMR serverless now available on Graviton, you get even lower TCO because you don't need to spend time managing your clusters. For log and search analytics, we offer the OpenSearch open source project and then the OpenSearch service. The OpenSearch project is highly scalable distributed search and log analytics suite for use cases like real-time analytics, log analytics, and website search. OpenSearch is 100% open source, community-driven, and is offered under Apache 2.0 license. Since its launch last year, we have seen tremendous momentum with an adoption from developers and community partners. We have hundreds of contributors now, many individual contributors and contributors from organizations like SAP, Capital One, and more. In addition, we have over 40 partners who have built their projects on top of OpenSearch project. And we offer the OpenSearch service as the fully managed service for search and log analytics. With OpenSearch service, you can centralize and analyze logs from disparate systems and applications for real-time observability and threat detection. You can also build fast personalized search into your applications and websites. Optimized for Graviton, OpenSearch service gives you 40% or better price performance for your log and operational analytics. That's why we have tens of thousands of customers building their applications on top of OpenSearch. It's customers like Pinterest, Autodesk, Fox. I would like to share how LexisNexis, one of our OpenSearch service customer, built their AI-powered legal brief analysis using the service. As a global provider of information and analytics, LexisNexis wanted to streamline the brief writing process for their users. Writing high-quality briefs is not easy. Lawyers, case managers, and other researchers must search through tens of millions of documents to find the relevant information for their cases. It could be an arduous, error-prone, and time-consuming process. Using the ML capabilities in OpenSearch service, their AI-powered brief analysis system offers recommendations to strengthen briefs in just seconds. And then the best part is that their users love it. To make things even easier for customers like LexisNexis, we launched yesterday a serverless offering for OpenSearch. With OpenSearch Serverless, you are free to focus on what matters the most for your business, as you no longer have to worry about managing your clusters. OpenSearch Serverless is highly available out of the box and is continuously adjusting resources for even the most unpredictable workload, and you only pay for the resources that you use. Often with log data, customers are also building applications to respond to that data in real time. That's why we have Amazon MSK and Amazon Kinesis. For real-time applications built on top of open source projects like Kafka and Flink, MSK and Kinesis Data Analytics take care of all the heavy lifting of managing and scaling these frameworks, so you can spend that time enhancing your applications. In addition, MSK provides up to 3 times better price performance when compared to self-managed Kafka for the most demanding applications. And we are making it even easier and cost-effective for you to build real-time applications. With the Data Viewer, you can now inspect your data streams right from the AWS Management Console so that you can understand your data streams and troubleshoot issues. And with MSK tiered storage, you can save up to 50% of the cost for your historical data. In fact, tens of thousands of customers are building stream processing applications using MSK and Kinesis. For example, using this service, Disney Plus is personalizing the experience for tens of millions of streaming customers. And GE Renewable Energy is monitoring and doing predictive maintenance of their wind turbines. Now, I'd like to invite one of our customers, Airbnb, who use both the OpenSearch service and Kinesis to solve their observability challenges. Please welcome Saurabh Mehta, Engineering Leader, Observability at Airbnb.
Thank you. Hi, everyone. My name is Saurabh. I work for Airbnb. I'm here to share our story for the observability logging that we built upon OpenSearch and Amazon Kinesis data stream. But first, a few fast facts about Airbnb. We are a global platform that operates in more than 220 countries and regions. Millions of people use our platform. Millions of homes are listed on our platform. And it's very important for us to provide a safe and reliable and secure experience for our guests and users. As we continue to grow, like that underlying infrastructure that powers the platform also grew with it. And that created some unique challenges. So specifically talking about the logging challenges, that came up with the growth and the scale. So we were running large pet clusters, which were hard to provision and upgrade with no capacity management. As true with any observability data, not all the logs are being queried. So most of our logs were like just sitting there. The solution also didn't have any tier storage, and everything was stored together in a one giant cluster. And that pushed the logs, the cost very higher. And our logs were growing almost at the 2x of the scale every year. So this is how our logging architecture looked. So we had from the beginning, like our logging infrastructure was built upon OpenSearch, but we were using unstructured logs for the instrumentation. And every team was using their own favorite library to instrument the logging. For collection, we were using rsyslog to push this data to external cluster on the external Logstash clusters, and from there was another Logstash cluster which pushed it to Elasticsearch. And then we were storing that in the JSON format in the self-managed Elasticsearch cluster, and we had Kibanas to provide that access. As you can see, there was a lot of data movement happening in the previous architecture. And at that time, our compute environment was also relatively homogeneous. We were running on bare EC2 nodes, and all the provisioning was done through Chef, which had another challenges with respect to the operations. So that pushed us to rethink what we really want to do for the logging and what matters for our business. Mainly, we cared about supporting our growing infrastructure needs with a reliable, cost-efficient, and a performant solution. In terms of computing, we wanted to have like smaller cluster, cater to the use cases so that we can scale and grow and not to overtax like the entire use cases. So, and then we wanted better isolation with quota enforcement, along with automation to replace the bad nodes, and we can take the regular snapshot of the data. We also wanted our solution to be cost effective, so it scales linearly with our infrastructure needs and performant enough so that we can use it for active debugging when there's an outage on the site. So with all this, we settled down with the solution to build upon AWS Kinesis data stream and the OpenSearch as it meets all of our requirement. Specifically talking about the growth, the first change that we made, we were going from self-managing OpenSearch cluster to AWS managed OpenSearch. It allows us to simplify our operations with Terraform as our cloud provisioning tool. What used to take multiple days and required careful monitoring can now be done in hours, mostly hands-off. And with speedier change rollout, it became feasible to automate cluster resizing closer to the usage rather than actually over-provisioning. Now, specifically talking about the cost efficiency, we wanted like a tier storage, which can actually, so we can push the older logs to a storage for which the queries are not coming from. So, and then by switching over to the structured logging format, it helped us to optimize for the instance types. So this is to showcase how our architecture looks today with building upon Amazon services. We have structured logging from all of our services. We have Filebeats, which actually collects the data and pushes to the Amazon Kinesis data stream, and we have the Logstash clusters to collect that, and then further to store the data in the Amazon OpenSearch service. And we provide all the access to the Kibana for our internal engineering teams. So this, today we ingest almost 8 times as much logs per day as we did back in 2017, while only using 25% more disk and 40% more instances than before. And we also run 10 times more cluster. As you can see from this, like we are able to control the cost. So our experience with logging and leveraging the open source software had taught us few things. The first benefit is the community. Our log pipeline architecture was not unique. Many organizations leverage the same components in similar way. That means many problems we encountered were also not unique. Popular open source projects enjoy broad user base and pervasive knowledge sharing. It was super easy for us to look up for the issues on Stack Overflow or the internet and find the solution and be more effective. The second benefit that we observed was the velocity. The pool of contributors to open source project is vastly larger than any single organization. New features are constantly being added to the OpenSearch software. The high pace of innovation is something that few private organizations can match. With the third benefit that we observed was the transparency. Code that is out in the open have many eyes on them, and that is higher quality and more secure, which was one of the requirements for us. For these reasons, when given a choice between open source or a vendor solution, we would pick the open source every time. So what are we doing next for the logging architecture? As you can see from the theme, we are moving more and more towards open standards and open source software. OpenTelemetry is one of the popular software and having an integration with OpenSearch. So we are right now on a journey to actually move to leverage OpenTelemetry across our infrastructure for logs and other observability signals. We also want to unlock more value out of the data that we collect by providing the correlations between the logs and the traces, and building more aggregation functions, and providing the automation through control loops. And then in the spirit of openness, we also wanted to open the data for all of our engineering teams so that they can leverage it either through query language or through APIs and the unified tooling. So that was our journey, and it was great to be partnered with AWS teams and working to provide these services back to us. Thank you, everyone, and I'll give it back to Jeetu.
Thank you, Saurabh. Thank you for the partnership on your journey. So as we saw in the LexisNexis example, the worlds of analytics and machine learning is coming together to give you even more value from your data. Data scientists today spend majority of their time preparing the data for machine learning tasks. That's why we are bringing access to analytical services right from SageMaker Studio. Now, a data scientist can use Spark in EMR or Glue for Ray right from SageMaker Studio for fast data preparation. With this experience, data scientists have seamless and governed access to data in data lakes and data warehouses for their ML workloads. We now have an integrated experience across big data processing and machine learning in SageMaker Studio. We're also bringing the power of machine learning to data analysts, developers, and BI users. For example, a developer can use Aurora ML to add low latency and real-time ML predictions using familiar SQL commands so that the application can do personalization or fraud detection. With Redshift ML, a SQL developer can build, train, and deploy ML models quickly right from Redshift using SageMaker. We are democratizing machine learning for SQL developers. One of our customers, Jobcase, built an ML-based recommendation system to match new jobs with their over 10 million active members. And the system performs billions of predictions in just minutes. And this system improved their customer satisfaction and grew their business. You can also leverage machine learning to make it easy for business users to understand and act on data. QuickSight ML Insights, powered by SageMaker Autopilot, enables BI authors without ML expertise to add powerful capabilities like anomaly detection and forecasting into their dashboards. Customers like Expedia love this feature. They use the out-of-the-box ML Insights to continuously monitor their business performance, respond to changes, and project future trends. This is an instance of what is possible when you have the right foundation that breaks down data silos with the right governance and brings machine learning and analytics together. That's why over 1.5 million customers build their modern data strategy on AWS. Now, to become truly data-driven, you want to put your data in the hands of everyone in your organization. And that's why we built QuickSight. We built a QuickSight to scale to everyone in your organization. At Amazon, over 425,000 employees use QuickSight to be more effective in their jobs. We built QuickSight to empower everyone in the organization, the experts and the end users alike. The experts can build and interact with rich dashboards, and the end users can ask questions in plain language. And we built QuickSight to bring data everywhere, in dashboards and in your applications through embedding. Let's talk about why QuickSight is the best BI service for your organization. With QuickSight, you get a serverless BI systems that can handle all your needs. You can build rich interactive dashboards, embed them in your applications, and enable them for natural language query. And now you can deliver your dashboards as paginated reports to everyone in your organization. With this new QuickSight feature announced yesterday at the keynote, you can consolidate all your enterprise BI needs in one service, QuickSight. You can fully customize the look and feel of your report and customize your delivery schedules. You can also archive your reports for up to 1 year for compliance. We're also making QuickSight-Q smarter. We launched QuickSight-Q last year to enable everyone in the organization to get answers to their questions using natural language. Customers like Forward Safety, a workplace safety management company, use QuickSight-Q to extend life-saving safety analytics to their end users in the field. Their users can ask, which risk will be highest next week? And Q would automatically generate the right visual. Now, you've made Q even smarter. In addition to answering questions like, what was my revenue last month? Q can now answer questions like, why did my revenue change last month? And what will be my revenue next month? With automated data preparation, you can now prepare your data in Q in minutes instead of days. We are making it even easier to adopt QuickSight across your organization. Today, we are expanding the set of API to programmatically create and modify QuickSight dashboards and reports. With this expanded set of APIs, you can easily integrate QuickSight into your code deployment pipelines. You can also automate your migration from other BI solutions to modernize your BI on QuickSight. Now, what about cost? We have priced QuickSight to scale to everyone in the organization. With QuickSight, you only need one service to meet all your BI needs. Dashboards, reports, embedded analytics, all enabled with natural language query. We continue to innovate rapidly with over 80 features launched so far just this year. It's serverless and fully managed, hence it is easy to operate regardless of your scale. And with consumption-based pricing and low cost for readers, QuickSight is the most affordable option to put data in the hands of everyone in your organization. To recap, today we talked about how you can build your modern data strategy on AWS Analytics Services and break down your data silos by connecting your data lake and data warehouses. Break down your system silos by connecting machine learning and analytics. And break down people silos by putting data in the hands of everyone in your organization. With the modern data architecture built on AWS, the Octane team was able to move fast on their product investment decisions. They came together and created a project in Amazon Data Zone. They were able to search and find all the relevant information in the Data Zone catalog because each team had created the right data products to share across the organization. And they got started on the analytics on the same day. By using the power of purpose-built AWS Analytics and machine learning services, they created a proposal for Kate in a matter of days. And they will invest in a line of toys that fosters STEM learning among girls. To jumpstart and accelerate your own data flywheel, AWS offers programs like Data-Driven Everything and AWS Data Lab. And we have a suite of training and certification programs to build the right skills in your team. Talk to your account team about how you can participate in these programs. To learn more about many of the topics that I talked about, there are a lot of sessions that are happening today and tomorrow. Please join many of these sessions to learn more about the launches that is happening this week. And thank you for all of us from AWS Analytics, and have a fantastic re:Invent.